All right, welcome back. Now what we're going to do is we're going to set up the general matrix equation. So let's suppose that we have this matrix equation, AX equals B, and it represents a system of n linear equations in n variables. So, and it has a unique solution, okay? Then we can solve this by, we can solve for x, where x is equal to A inverse times B. Where A is the coefficient matrix, x is the column matrix of variables, and B is the column matrix of constants. Okay? And so, and the thing is if we have a unique solution, then we know that A is invertible, right? So A has to be invertible here, okay? And so the way we do this is just by using what we know from the previous videos, the properties of matrix multiplication and properties of the inverse, you know, so we can solve this easily. So if we have AX equal to B, right? And again, this, if the inverse exists, if there's a unique solution, and that means the inverse exists. So if the inverse exists, I can multiply on the left by A inverse. So I get A inverse AX equals A inverse B, right? And then A inverse A is just the identity, right? So I get I sub n times x is equal to A inverse times B. But then this is the identity matrix, which means that I sub n times x is just x. So I just get x back out and I get the result here. And so we're going to use that to solve systems of linear equations using the inverse.